NASA is preparing for a mission they call the Big Bang. Not the birth of the universe, but a desperate final attempt to keep alive the most distant machine humanity has ever created. Far beyond the planets, beyond the edge of the solar system, nearly 15 billion miles from Earth, a tiny spacecraft is still drifting through the darkness between the stars. That spacecraft is Voyager 1. And right now, it is slowly dying. Not because of a collision. Not because of a catastrophic failure. But because time itself is finally catching up to it. Launched in 1977, Voyager 1 was never supposed to survive this long. Its original mission was simple: fly past Jupiter and Saturn, capture images, collect scientific data, and eventually fall silent in the cold outer darkness of space. No one imagined it would become the first human-made object to leave the solar system. No one imagined it would still be operating nearly half a century later. Yet somehow, this aging spacecraft kept going. Past Jupiter. Past Saturn. Past the icy frontier of the Kuiper Belt. Through the heliosphere, the giant bubble of solar wind surrounding our solar system. And then, in 2012, Voyager 1 crossed the heliopause. The boundary where the sun's influence fades, and true interstellar space begins. For the first time in history, a machine built by human hands entered the vast gulf between the stars. And it did it using technology designed in the early 1970s. Its computers are weaker than modern calculators. Its memory is microscopic by today's standards. Its software occupies less space than a single modern image on a smartphone. Yet Voyager 1 continues to speak across impossible distances. Its power comes from a radioisotope thermoelectric generator, a device that converts heat from decaying plutonium into electricity. No solar panels. No rechargeable batteries. Just radioactive decay slowly producing enough power to keep the spacecraft alive. But that power source is fading. Every year, Voyager 1 loses a little more energy. At first, the losses were manageable. Then they became dangerous. Now, they have become critical. In February 2026, engineers at NASA Jet Propulsion Laboratory sent Voyager 1 a routine command. A simple roll maneuver designed to calibrate one of its instruments. It should have been ordinary. Instead, something unexpected happened. The spacecraft's power levels suddenly dropped. Not enough to destroy the probe immediately, but enough to trigger alarms back on Earth. Voyager carries an automatic self-preservation system called under-voltage fault protection. If the spacecraft detects dangerously low power, it begins shutting systems down automatically to protect itself. Once that process starts unexpectedly, recovering the spacecraft becomes extremely difficult. The engineering team had to act fast. But fast means something very different when your spacecraft is 15 billion miles away. Every command takes roughly 23 hours to arrive. Then hours more before the spacecraft responds. There are no real-time corrections. No second chances. No undo button. So in April 2026, NASA made a painful decision. They shut down one of Voyager 1's final science instruments, the Low-Energy Charged Particle Experiment, known as LECP. An instrument that had been operating almost continuously since 1977. For 49 years, it measured cosmic rays, ions, and energetic particles at the edge of known space. Now it went dark, not because it failed, but because Voyager simply no longer had enough power to keep it alive. That moment revealed how fragile the mission has become. Voyager 1 originally launched with 10 science instruments. Most have already been shut down over the decades to conserve energy. Only a few remain. And now the spacecraft is approaching a terrifying threshold. The challenge is no longer just keeping the science instruments operational. It is keeping Voyager itself alive. Its thrusters rely on hydrazine fuel. If those fuel lines freeze in the cold of interstellar space, the mission ends instantly and permanently. That means every watt matters. Every engineering decision has become a trade-off between science and survival. NASA's engineers describe the remaining power margins as razor-thin. Without intervention, Voyager the 1st of May only have about another year of full scientific operation remaining. Which is why they created something called the Big Bang. The Big Bang is not an explosion. It is a carefully planned reconfiguration of Voyager's entire power system. Engineers intend to shut down multiple components simultaneously, reroute energy, replace certain systems with lower power alternatives, and completely reshape the spacecraft's electrical balance. The goal is simple: buy Voyager more time. Maybe a few more years. Maybe long enough to push operations into the 2030s. But the risk is enormous. A mistake on a spacecraft this distant cannot easily be corrected. One bad calculation, one failed command, and Voyager 1 could vanish forever into silence. That is why NASA is first testing the procedure on Voyager, and if it works, something extraordinary could happen. Engineers intentionally left a tiny half-watt motor inside the LECP instrument running. A backup pathway. A final possibility. If enough power can be saved during the Big Bang reconfiguration, Voyager the 1st of May be able to switch that instrument back on. One final scientific glimpse into interstellar space from the most distant functioning instrument humanity has ever operated. Meanwhile, Voyager 1 continues moving outward. Relentlessly. Silently. Crossing the darkness at roughly 17 kilometers per second. And this year, it is expected to reach a distance never before achieved by anything built by human hands. One full light day from Earth. Think about that. The Sun is only 8 light minutes away. Voyager 1 will soon be 24 hours away at the speed of light itself. From that unimaginable distance, it still sends signals back to Earth. Faint whispers crossing interstellar space. Messages carrying data about magnetic fields, plasma waves, and the hidden environment between the stars. No other spacecraft is there. No backup exists. Whatever Voyager discovers in these final years may remain unique for decades. Eventually, the physics will win. Its remaining power will drop too low. The instruments will shut down one by one. Then the scientific data will stop. For a while, the carrier signal itself may continue. A lonely radio heartbeat drifting through the darkness. And eventually, even that will disappear. But Voyager 1 will keep moving. For thousands of years. Long after humanity changes. Long after the people who built it are gone. In roughly 40,000 years, it will pass near another star, a dim red dwarf called AC plus 793888. No one will be listening by then. No one will be sending commands. It will simply remain there, a silent artifact from an ancient civilization, carrying the golden record into the galaxy. A message from Earth. A memory of a species that once looked upward and decided to explore. And right now, against all expectations, Voyager 1 is still alive. Still moving. Still whispering back across the void. A tiny machine built in the 1970s, surviving at the edge of eternity.